Okay, let me share my presentation. Mm, Okay, so last class we seen about data systems and the file systems, hierarchy and all those things. So here there is yeah, fixed length records. So file organization database may be stored as a collection of files. Okay. Uh, As database, where to store the records, the database is a set of files. So each table or call it as a database, and we can create store as a separate file or maybe combine into a single file. And here each record tuple is called as a record. The record may be a fixed size or variable size. So how to implement them, how to store them in the system. So what are the disadvantages of each and every approach we will be discussing it. So last class we seen about fixed length record. So fixed length record we have fixed length for each and every record. So this record may take let us say 50 bytes or let us say it takes 50 bytes. So the totally each record will take only 50 bytes. So fixed length is allocated for each and every record. But here, if you let us say if you delete a record 3, okay, so it's a file is stored as a sequential file, and what happens is if you delete the record 3, then the system has to move all these records, okay, one by one. It has to compact, so that will takes a lot of time. So to avoid that, they go for other methods. So instead of compacting each and every record, they move the last record in the place of deleted record. So that is one way of reducing number of compacting, number of movement of records. So here also what happens is after you delete a lot of records, so you will have in between you have a lot of other records. So searching or indexing and all those things will takes a lot of time. So in that case, they go for other methods. So here they deleted the record, and so they deleted the record 3, and in that place they moved the record 4, and in record 4 place they moved record 5 like that. So record 6 is moved here. So this is a one way of compacting. It takes a lot of time because if we have 1000 records, even for one deleted record, we have a lot of movement. Compacting it takes a lot of time. So instead of that, they move the last record in the place of 3. So record 3 is deleted here. So in the place of 3, we move the record 11, which is in the bottom, which will be moved here in the place of record 3. But here the arrangement, this is not in a sequential order. So again, it will create a problem when we search for the question energy, we search for the record. So again, it has to be sorted and it has to be stored after some period of time. So there are other methods. So to avoid the deletion of records and all the compacting and all those things, now they implemented a pointer concept. It's called a free list. So it is a free space. So whichever deleted that will be stored in a free list. So the starting contains a header which points to the free records, so which are deleted or which are free. So here it is points to a free record. This has a pointer to the next free record and next free record, and finally it will have a null. This end of the free record. So this way they maintain the free list, but their pointers are not stored for the remaining records. So these records will not have any pointers. So only the free records will have the pointers. They will store only the free records as a separate list of pointers. So this avoids the compacting process. So unnecessary compacting is not required here. And the variable length records. So it's a very interesting one. So we use varchar character. Varchar is a variable. I mean, the field we declare as storage type is a varchar. Then the case is a variable length. Okay. So in that case, it will store variable length records. So in that case, how to store this information? So each and every record, each and every field. So here we have, let us say, row. This record salary. Okay. ID, name, department, and we have salary. Okay. Salary, it is fixed value because after that there is no, there is 8 bytes. Okay. So here, since it is a variable length records, so they store what is the starting location of the ID. So ID is 5 bytes. They store that. It starts at 21 and it has 5 bytes, 21 to 26. So 21, 5 bytes they store here. 21 its starting location, number of bytes is 5. So next one is it starts at 26, 21 to 25. 5 bytes means 21 to 25, not 26. So next one starts, name starts at 26th location. So name they mention here. So name they mention what is the number of characters here. There's a variable length, only what are the text stored there, that is the count will be stored in the record. Here Srinivasan, it is 10 bytes. Okay, so its starting location is 26 and the length of that Srinivasan, the name is 10 bytes. And next one, the computer science, it started 36. The length of that one is 10 bytes, including spaces. So that is stored here. So it will end at 45. So 46 we have the salary. So it will, but we will not store the salary because it's a fixed length. So it will be stored in this header itself. The header, they will store the variable length records, then the remaining fixed length records. Okay, so this way they store the information. Yeah, so this is how we mention the variable length records using offset and the length of each and every variable length record. The attributes or the attributes, the variable length each and every attribute will be mentioned using offset and length. Okay. So it contains in the variable length records, multiple records will be stored. So in that case, if you delete any record, then the free space list will be maintained. So here we have the free space list. Okay. So the first one will point to the free space list. Okay. And the next record, the free space list will be mentioned here. It will point to the other free spaces. And here the next one we have the first record, record 1, record 2, record 3, record 4, starting location, the address and all those things. So it will point to the first record. I think it is pointing here. So this record 1 is stored in this place, record 2 is. So we can store it in variable length records, we can store it in any other manner. So the records are here. So records are stored here, which has a pointer here. So the header contains a pointer to the records. So this way We call it as a slotted page structure. This is how variable length records are stored. So here we are seeing only a single record. So if you have multiple records, then all this information will be stored in a slotted page structure. So here in the solid base structure, we have number of record entries in your system. So that is, it contains how many record entries and what is the free space location. So that is, if you have 10 records, it will mention 10 records and the free space address, the end of free space in the block. So free space, what is the end of free space? That will be pointed here, and location and size of each record. So that will be stored in this. It will have this location and size, and it will point to that particular record. So there we have the detailed each and every attribute, the length and offset and length. Okay. So here the records can move around within a page and keep contiguous with no space between them. That means that you can move the records. I mean, you have to store them in an order because we are having the location and size of each and every record. So location and size of each and every record is there. So we can store it in this like a list. We can store it in anywhere, and we have a pointers which points to them. So it's about variable length records and organization of records and files in the system. How to store them? There are various ways. Sequential is each and every record stored one by one. That is usually a sequential method. And we have a heap based for storing as in the file, and the hashing also they use it. And we see about all these things in as also a B tree. So all those things will be seen in the next few classes in detail. Okay. So sequential file organization. So here it talks about file, storing the records in a file, the system, the hard disk, how we are storing the records in a file. Okay. So the structure of the previous two things is how the records are represented. Fixed length records or variable length records, how records are represented in your database system, and how it is stored is whether you can go for hashing or sequential, so or tree representations or keep. So any one of these representations they use. So here they store it in a sequential file organization. So here they ordered by the search key. So based on the search key, it will be like maybe the ID, maybe the search key. So we order them based on the search key. So this way we store them in a sequential order, and these are all fixed length records. We consider fixed length records. So it also points to the next record. So the end of this record will point to the next record. The end of this record will point to the next record. So that's what they mentioned here. So that is how sequential files, the records are stored in a sequential file organization. And what happens if there is any deletion or insertion? Okay. So in that case, since it is sequential file, so what happens is we need when we insert a value here. Let us say we're inserting a value here. So in that case, what happens is you are inserting this value. Okay. So then it's a sequential file. Then you have to move all these records down, and you have to insert the value. To avoid that, so they use the pointers here. Like the previous, we also see the pointer. So here what they do is the pointer will point to this location in the file, and again it will point to the next record. So this way they avoid the movement of what do you say records, unnecessary records, and even deletion also they remove and they point to the next record. So if you delete this value, so this record will point to the next record. So this way they do the deletion. And if there is no free space, because the file size, let us say the file size is a fixed one, which has some 2 free blocks are there. Okay, if there is no free blocks, then they go for overflow block. So overflow block means they create another new block at the end and they will insert there. So here that is the case here. So they want to insert this one. So that is 322. So here they have to insert. There is no free space here. So they move it to the end. That's called as overflow block. So this called as overflow block, and they adjust the pointers. So in between, if there is no free space, we cannot insert there. So then we use overflow block and they adjust the pointers. Okay, so there is a sequence file organization. So remaining things I will discuss again. Okay. Um, okay, that's all today's class. Next class we see indexing and all those things. So any doubt in this? Any doubt? So next class we see about indexing techniques. Guys, people are there. No answers. So I think people are went. They'll come back again after around 11 o'clock. Is it so? Okay, I'm leaving the meeting.